We're going to start a new topic here of probability with this video, answering the question, how do we calculate basic probabilities? And we're going to start off with the theory, kind of the formulas or the equations, and then we'll dive into actually working out some examples. There's really 4 basic probability questions. The most basic is just to calculate the probability that some event occurs. And the way we can calculate probability is we take what we want and divide it by the number of options available. So if we want to roll a 3 on a standard 6-sided die, we want one of the numbers out of the 6 options, and 1/6 would be the probability. We have some things, though, that are called compound probabilities. That are probably more useful in application. The first is when we want to calculate the probability that 2 things occur together, the probability of A and B. Maybe the probability that it's sunny outside and that it's a weekend. We want both of those things to happen at the same time. And the way we calculate the probability of A and B is we take the probability of A times the probability of B given that A happened. So the probability of B may be different or the same depending on if A happened or not. But it's important that in our formula we say we multiply by B given that A happened. We'll look at some examples in a minute. The next option is the probability of A or B. That's the probability of either or both. I might be interested in the probability that it's sunny outside or above 80 degrees. It's OK if it's cloudy as long as it's above 80 degrees, or sunny's good as well even if it's cold, or both. It doesn't really matter. And the way we calculate an or probability is we take the probability of the first one and add the probability of the second one. But unfortunately, that sometimes means the 2 overlap. And so we'll subtract the probability of A and B, so we don't double count. And the third type of probability was kind of implied in the definition or the formula of the and that is the given, the probability of A given B. And here, what A given B means is that B has occurred. We know B is true, so we're only going to look at B to find A. And we can calculate it with a formula as the probability of both A and B divided by the probability of the given information. So if the B was given, the B goes in the denominator. So really 4 probability formulas. We're going to take a look at these in several different contexts. The first context is going to be with just simply rolling a die. Let's look at some examples. Let's say we roll a die numbered 1 through 6, a standard 6-sided die. And we want to first calculate the probability that we roll a prime number. Well, if I think about primes, the primes are 2, 3, 5, 7, 11, 13. But 2, 3, 5 are the only possibilities. So the number we want, there are 3 options that we want divided by the 6 options that are total. Well, that'll reduce to a fraction of 1/2. Or probabilities could be expressed as a decimal. 1 divided by 2 is 0.5. But probabilities can also be expressed as a percentage by moving the decimal point twice. So depending on what format the answer is asking for, you might give your probability answer as a fraction, decimal, or a percent. Let's do the probability that we get a prime or an odd. Or implies that we're going to be doing some addition. So again, our primes are 2, 3, and 5. The odds are 1, 3, and 5. Using our formula, we said to calculate an OR, we take the probability of the first, the probability that we get a prime. There are 3 out of 6 primes, plus the probability of the second part, the odds. Well, there's 3 out of 6 odds. But then our formula said we had to subtract where they overlap. 2, 3, 5, and 1, 3, and 5 have the numbers 3 and 5 in common. So we're going to subtract that overlap of 2 out of 6 choices. When we do that, we'll end up with 6 is 4 out of 6, which reduces to 2/3 as a fraction, or 67.67 as a decimal, or 67%, depending on which format we actually want to calculate. Now, when I did this, we actually used the formula. We used the formula for calculating an OR probability. We found the probability of prime plus the probability of odd minus the probability of both. That's using the formula. Without the formula, though, I could have also worked this out using the definition. There's 6 options, 1, 2, 3, 4, 5, and 6. The prime numbers are 2, 3, and 5. The odd numbers are 1, 3, and 5, which means the ones I want, there's 4 options I want out of 6, and that would have given us the same 2/3 using the definition instead of the formula. 2 ways to get at the same answer. Let's roll the die again, though, and instead of doing a prime or an odd, we're going to look for the probability that we get a prime and an odd. The formula for prime and odd, if I use the formula method, says we take the probability that we get a prime times the probability of odd given its prime. So let's break that down. The primes we said are 2, 3, and 5. So there are 3 out of 6 primes times the probability of odd given it's a prime. So if I just look at the primes, there are 3 to choose from, and 2 of them are actually prime. So when I multiply these out, we get 6 out of 18, which is going to reduce to 1/3, or 0.33, or 33%, depending if we want a percent, decimal, or fraction for our answer. Again, though, we could have used our definition instead of the formulas. Again, the numbers are 1, 2, 3, 4, 5, 6. And by definition, prime and odd, 1 is not prime, 2 is not odd, 3 is both prime and odd at the same time. 4 is not odd or prime. 5 is both. 6 is not. So really, there's 2 out of 6, which reduces to 1/3, that are both prime and odd at the same time. So again, you can use the formula, or you can use the definition. Let's do one more. We haven't done the given, the probability of prime given odd. If we use the formula for a given, it says we take the probability of both prime and odd, and we divide by the probability of the second part, the probability of an odd. Well, we've already calculated the probability of prime and odd in part C. That is 1/3. Divided by the probability that it's odd. Well, 3 out of 6 are odd. And if we multiply by the reciprocal, we get 1/3 times 6/3, which is 6/9, which reduces down to 2/3, 0.67, or 67%, depending on the format we want to give our answer in. Now, this feels a little weird. It's probably better with this one, in this case, to look at the definition. We have all the numbers 1, 2, 3, 4, 5, and 6. Yes, it can be any of those numbers, but when we're given the information, given that it's odd, we only look at the odds. 2, 4, and 6 do not exist. We've shrunk the sample space down to just look at the odd numbers. And we're saying just of the odd numbers, not of all the possibilities, but just of the odd numbers, what's the probability it's prime? Well, 3 and 5 are primes, so the probability is 2 out of 3. So that's with our rolling the dice example, listing out our possibilities. That might be a little cumbersome. Let's try another layout as we do another example, using what's called a contingency table. A contingency table lists out all the total possibilities of 2 variables. Let's say I'm interested in comparing gender and eye color. Let's say eye color could be blue, brown, or other. And gender, our surveys responded with either male or female. And I did my survey, and we found out there were 15 blue-eyed male, 24 females. With brown eyes, 31 male, 29 female. Other colored eyes, 8 male, and 4 female. And quite often with contingency tables, it's nice to calculate a total row and a total column. It'll help us with the probabilities here in a minute. So 15 plus 24, that's 39 blue eyes. 31 plus 29, that's 60 brown eyes. 8 plus 4 is 12 other eyes. And if we total the columns, 15 plus 31 plus 8 is 54 males. 24 plus 29 plus 4 is 57 females. And if we add either the row or the column, the overall total should come out to 111. Contingency tables are nice because they organize the data in such a way that we can easily pull off the needed probabilities that we're looking for. For example, if I wanted to calculate the probability someone has brown eyes, I can easily see a brown-eyed total of 60 out of a total number of interviewees of 111. So I just have to say that's 60 out of 111. Make that a decimal. It's approximately 0.54 or 54%. What if I want to know the probability of brown eyes or female? Here we're going to have to use our OR formula that says we're going to take the probability of brown plus the probability of female, and then we'll subtract the probability of, I'm just going to write both. So brown-eyed total was 60 out of 111. Females, total females were 57 out of 111. The problem is these 29 in the middle were counted in both the brown row and the female column. Those 29 people were counted twice. So we have to subtract off the both. Where they overlap is 29 out of 111. And when we do that, we should get 88 out of 111, or 0.79, approximately 79%. Let's look at the AND case. Let's find the probability of brown and female. What's nice about the contingency table is we can see where brown and female are overlapping is right in this middle with these 29 individuals. So 29 out of the 111 people had both brown eyes and were female. That comes out to approximately 0.26 or 26%. Let's do a given. The probability that they have brown eyes given that they are a female. Now again, what the given says is nothing else matters except the information that's given to us. Given female. So all we're going to do is look just at the female column. Nobody else exists in this survey. And what's the probability someone has brown eyes? Well, there's 29 with brown eyes. Out of the total is now 57. Because we're just looking at the given females. We're not looking at anybody else. There's only 57 total options, which gives us a probability of 0.51 approximately, or 51%. So the contingency table is really, really nice to help us organize our data and pull these various probabilities off of the chart. There's another nice visual way to look at probabilities, and that is using what is called the Venn diagram. The Venn diagram shows numbers in overlapping circles. So for example, if I want to know where people are getting their movies from, one circle might represent they're getting them from Netflix. Another circle that overlaps is going to say these are the ones that are getting them from Hulu. And another circle that overlaps says no, they're getting them from their cable. And maybe there's 15 in the top left, 21 in the top center, 13 in the top right. Down the middle row, we've got 7, 11, and 6. And in the bottom, 10. And even outside of the circles, I can have a number. And what those numbers represent is how many fall in those ranges. For example, that 21 falls both in the Netflix and Hulu circle. Those 21 people get their movies from both Netflix and Hulu. Notice the 7 are people who get Netflix and cable. 6 are people who get Hulu and cable. 4, outside of the circle, are people who use none of these services. And the 11 in the center use all 3. Similar to the contingency table, we can use these Venn diagrams to pull the information off that we want. For example, if I want to know the probability a random subscriber uses Hulu, well, then I'm going to look at the Hulu circle. Exclusively the Hulu circle. Notice there's 4 numbers in there. We need to combine them all together because they all use Hulu. So there's 21 plus 13 plus 11 plus 6 people using Hulu out of a total, well, that would be everybody. So if I add 4 plus 10 plus 7 plus 6 plus 11 plus 13 plus 21 plus 15, if we add it all together, the total, I'll put at the bottom, is 87 people. So to get the probability, we divide by 87. Adding the numerators so I don't get in trouble with order of operations, we have 51 out of 87 subscribing to Hulu. That would be 0.59 approximately, or 59%. But we can also do our compound probabilities using the Venn diagram in a very similar way. Let's find the probability someone subscribes to Hulu. I'm going to use an H for Hulu, or Netflix. Or means you can be in either one or both. So now we're looking at the Hulu circle, but we're also looking at the Netflix circle. Anyone who falls in either of those spaces. Well, there's lots of numbers there. There's a 15 plus a 21 plus a 13 plus a 7 plus 11 plus 6 out of the total of 87 people. If you add that up, that gives us 73 out of 87, or approximately 0.84 or 84% for the probability of a Hulu or Netflix subscriber. What happens if we change it, though, to an and? Hulu and Netflix. With the and means we want both of them to occur. We're looking for where they overlap. And you see the Hulu circle and the Netflix circle are overlapping in the center red area, where the only numbers there are the 21 and the 11 that fall in both circles out of 87. Or 32 out of 87, which is approximately 0.37 or 37%. The last one we have is the given. What's the probability that they're Hulu given that they're a Netflix subscriber? Now, this is going to be a little different because given says we're going to ignore everyone outside of the given information. Given is Netflix. So I'm going to only look at the Netflix circle, now circled in purple. Nobody else exists. And I want to know, of those people, how many are Hulu subscribers? Well, there's the 21 and the 11 Hulu subscribers, 21 plus 11. But when we divide by the total, with the given, we're just looking at that smaller circle. So it's not all 87. Now it's just those inside the purple circle. There's a 15, a 21, a 7, and an 11 inside that smaller circle. Just those 4 numbers, because that's what's given to us. Given means we exclusively look at that group. And when we add now, we get 32 out of 54, which is 0.59 or 59%. So in this video, we've been looking at basic probabilities with simple probability, compound probabilities with or, and given. We've looked at situations where we've described the situation, such as rolling a die. We've looked at contingency tables, and we've looked at Venn diagrams. Each of those can be used to help us calculate these probabilities. With probabilities, the best way to get good at them is to practice. So now it's your turn. Let me know if you have any questions.